Hi and welcome to this tutorial. My name is Maggie. Machine learning is a vital subset of AI which can be used in Earth observation to classify and manipulate large amounts of data, leveraging the benefits of a substantial amount of satellite imagery and climate data available. In this video, we will work with sea ice and lead classification. We will walk through Python coding using Google Collaboratory or Google Colab, which is a great platform for running AI projects because it provides free access to GPU resources and no installations because it can run from your browser. You can sign into Google Colab using your Google account. If you don't have a Google account yet, you can visit their website to create one. You want to start by opening the Jupyter Notebook, which is available on the Moodle page via a link. You then want to navigate to this introduction to AI machine learning and click on the Google Drive. Here you can download the Week 2 folder. You need to then unzip it and upload it to your own Google Drive. For the first interactive code on Google Colab, click on this. Hit the Connect button to connect your session, and then mount your own Google Drive. You'll need to give it permissions. We import the packages, and then you want to change the path to your own path. To do this, go to the left and navigate to Week 2. Click on the three dots next to Sea Ice and Lead Classification file, and copy the path. You want to paste it in here. Change the mask area to the mask that corresponds to your mask. In this case, it's sample 1, so we do 100, 700, 300, and 1000. Make sure it's running. Change the mask. Mine is followed by my student number. Run the next section of code, making sure that it extracts the correct section or region of interest and that it plots images. Some of the following cells involve the creation of 3x3 patches, which help train each pixel with the help of the surrounding pixels. Bear in mind we have 21 bands, and we need to repeat the process across the whole image. At the edges and corners, we need to factor in that not all pixels will be fully surrounded by 8 pixels. The next few cells create a balance between sea ice and lead in our data. The last step is to save the files as train and test files. Open the second Google Colab file. This chapter helps us with surface discrimination. We use 21 bands of imagery, so we have 59,000 pixels. Some data is randomly selected for training, and some is then selected for testing. Hit the Connect button and mount your drive. Install the relevant packages, and then change the path to your own path, where you, in the last section, saved the X and Y training and test files. Specify the paths to each of your X and Y train and test files. You can do so by clicking on the three dots next to these files. Next is the CNN section. CNNs learn spatial hierarchies using several layers that firstly detects edges, then combine the edges to detect shapes, and further layers then might detect more complex structures. Revert to the shape that is consistent with the data that you will use. This model can be deployed on future input features. Random forests are important AI tools for classification tasks. They use a subset of different areas of the data to make predictions. Here's the code using the function CLF, and we use it to define X-train reshapes. Vision transformers are a more recent AI tool and are specialized for image classification. They're very good at training, and because they take a number of steps, they can be scaled up. The next step is cross-validation and model selection, which are important tools for preventing overfitting. On the left you can see an underfitted curve, and on the right you can see an overfitted curve. We want to achieve something like the one in the middle. Overfitting and underfitting can be affected by the way we choose to classify lead and ice. For example, if the top left was 0, it basically means that all ice should be classified as ice. And if the bottom right is 0, then it basically means that all lead must be lead. In particular, cross-validation evaluates the performance of a model by splitting the dataset into a training set and a validation set multiple of times. The most common method is k-fold cross-validation. In this validation method, The data is randomly partitioned into k number of equal-sized subsets, and then one is chosen as the validation subset. Here is the code for that part. Make sure to look at the numbers below because they are important for quantifying the results. After following these steps, you can start to build a simple model classifying sea ice and lead. Thank you for watching, and good luck with AI.